Alrighty, let's tackle this law of cosines. Um, you don't really get a choice on whether you use law of sines or cosines because you have to go based on the information that's given. So with the law of sines, we needed to have like big A, little a, like a pair of opposite angle and sides. This is kind of the catch-all for if you do not. Now this is the formula. The A, B, and C have to kind of be used interchangeably. You can't just be obsessed with them staying A, B, C. What has to happen though is that one of these is unknown. So you're either looking for the side that's out in the front of the equal sign, or the angle at the end. And they also have to be the same letters. So there's going to be big A, big B, little b on the ends. Then these others in here, these are just going to be whatever the other two given sides are. So don't obsess over A, B, C, and so on. So let's just tackle this and see. And again, we need to figure out how to find sides and then later angles. So let's do it. And again, no Pythagorean theorem, but we do get a 180 add up on the angle measures. So this is specifically telling us to find side A, which would be this one across from the 123. Keep in mind, across from this makes the 21B, across from C makes the 30 side C. But like I was just trying to say, don't be too obsessed about what letters you're using. Because for example, in this case, if we're finding side A, that is my unknown, and I have to start with it. It also means that at the very end, I have to have cosine A, because like I said up here, whatever your unknown is, you have to use the same letter. So if I start with A squared, then the other two given sides go in for the rest of this formula. So it's going to be 21 squared plus 30 squared minus 2 times 21 times 30 times the cosine of angle A, which is 123. So that's what I mean. These both have to be the same letter. This is angle A, this is side A. When you're finding sides, all of this is numbers. There's nothing that's unknown on the right. So you just put the whole entire thing into your calculator carefully. So if you do that, 21 squared plus 30 squared minus 2 times 21 times 30 times the cosine, because this is the law of cosines, 123, you should end up with 2027.24-ish. But that's not A, that's A squared. So we're going to square root the whole thing, not worried about plus or minus, since it's the length of a side, it can't be negative. And that comes out to be about 45.0. So that makes sense when I look at the picture too, because this should be bigger than both of the others since it's across from the biggest angle. Okay, that is easy enough. So here, find side C. Side C will be this one. That makes these the other two given sides. And when I go to set up my formula, I need to start with C squared because that's my unknown. Then it doesn't matter which of the other two goes first. So I'm going to have 29 squared plus 13 squared minus 2 times 29 times 13 times the cosine of angle C, which is 41. And again, this entire side is all numbers, so I can just go straight through my calculator, type it all in, absolutely do it so that you can see if you get the same number as me. So 29 squared plus 13 squared minus 2 times 29 times 13 times cosine 41 should all come out to be about 440. So then when I square root that, I'm getting a side length of 20.99, so probably about a 21. So this side would be 21. So it's actually pretty easy to use in that manner. Here, this one's crammed in here weird. Side B, if you know angle B, which is good because that's got to be the pair at the beginning and the end. And then these are going to be my other two given sides. So if I'm looking for B squared, I put that out front. Then I'll have the other two sides, 11 squared plus 14 squared minus 2 times 11 times 14. The 2, remember, is part of the formula. And then cosine has to be of angle B since I started with side B, so there it is. And I would just type the whole thing into my calculator, 11 squared plus 14 squared minus 2 times 11 times 14 times the cosine of 34 and I'm getting that b squared is 61.6. And if I use the square root of that, I end up with a b value of 7.85-ish. So it's pretty easy to use when you're finding the sides. It's kind of tricky to use when you're finding the angles. This kind of got wonky. So use the law of cosines to find unknown angles. So now we're going to switch to how do I find angles? Keep in mind, angles always require inverse, so I'm going to have to use this at the end of my solving every time. They're not right triangles, but the angles will still add up to 180, so I can use that piece of information to help me as well. Okay, so let's do what this says. Let's go ahead and find the angles that they gave you. So we're looking for angle A. Okay, if we're looking for angle A, then A has to be the little a has to go out front. Sorry, because we always have to have the matching pair. So in our picture, little a will be a one across from angle A, little b will be across from B, and little c will be across from C. So if I'm going to be looking for the measure of angle A at the end, I need to start with side A at the beginning. So that's going to be the one sitting here. Then the 17 squared plus 11 squared minus 2 times 17 times 11. And then here is where it gets a little dicey. This is the thing that I don't know. So like in algebra, this would be my x. You cannot put everything into your calculator anymore. I always call it the law of cosines waltz. A waltz goes 1, 2, 3, 1, 2, 3, 1, 2, 3. And when you're going to do cosine inverse, do the law of cosines waltz, which means you can put this one number into your calculator and then these two numbers, so 17 squared plus 11 squared, and then these three numbers. There's your law of cosines waltz, 1, 2, 3. You can put in one number, then two numbers, and then 2 times 17 times 11. Those three numbers are 374. So right now we have something sort of in the format of like 5 equals 2 minus 3x. You would not be able to put these 2 and 3 together, so don't go putting these together. You would take away the 2 first, so that's what we do here, is we take away the 410 first. That leaves me with negative 310 equals negative 374, and since that's multiplied by the cosine every time, you end up dividing it. So your numbers will change each time, but your process will be the same every single time. Do this little waltz, one number, two numbers, three numbers, subtract the first guy, divide by the one that's attached. Now at that point, I'm going to get a weird decimal, because when I divide negative 310 by negative 374, I get 0.8288-ish. That is not my angle, that's the cosine of my angle. And I remind myself, hey, I'm finding an angle, so I need to do cosine inverse of that decimal. When I do, I get a 34-degree measure for angle A. So it's always the same process. The 1, 2, 3 waltz, subtract the first number, divide by the one attached, cosine inverse. Let's try again. Here we're going to find angle C, so we'll need to start with side C. Side C is going to be the one across from C, and then the others can just be the other two. I don't care what order. So I'm starting with c squared, so I'm going to have 21.9 squared equals, and then the other two, 10.4 squared plus 18 squared minus 2 times 10.4 times 18 times the cosine of the angle I'm trying to find. So that was a c. I needed that to be a c. I'm looking for an angle, so I got to do my 1, 2, 3 waltz, so I can do this one number, these two numbers, and these three numbers. So 21.9 squared is going to put me at 479.61. Then 10.4 squared plus 18 squared is going to put me at 432.16. And then I'm going to do 2 times 10.4 times the 18. So I'm doing the three numbers and getting 374.4. And that's the one that's attached to the cosine. Then I always subtract this next number because I can't do these two numbers together because one's attached to my x. So I'm taking away the 432, 16, and I'm ending up with 47.45. And then I always, after subtracting, divide by this number that's attached to my cosine. And that turns into my ugly decimal, which is my cosine C. So I always do cosine inverse of that number. So if I do cosine inverse of that answer of negative 0.1267-ish, then I get that the measure of angle C comes out to be about 97.3 degrees. So it's always the same. Do your 1, 2, 3 numbers, subtract this, divide by the one attached, do cosine inverse. So it's not terrible. It's not quite as easy as when you just had to do square root to find the side, but the process, if you practice it a few times, it's pretty straightforward. Hope that helps. Bye, guys.